This is an introduction to the IV Characteristics Lab apparatus. So this is the main IV baseboard. On this, we have a few different things. So this guy here, this is the reference resistor. And you can see there are some wires on either side. Those are electrically connected to either side of a reference resistor. This here is where the power supply connects. So you're using the USB power supply, and that's going to connect here when you want to turn on the power to your IV baseboard. Over here, we have the connections for our circuit elements. So if I tilt it up a little bit, you can actually see there are two prongs that stick up. And any of your circuit elements have these black plastic connectors on the bottom that allow you to securely connect it to the IV baseboard. And then this blue block and this dial here, that is the variable resistor. So by turning this dial, that allows me to change the value of the variable resistor. So note that it does have an extreme on either end, so I can turn it all the way clockwise or I can turn it all the way counterclockwise, and that is the full range of our variable resistor. So you can't just keep turning it up or keep turning it down. There is a limited range on what you can use. So keep that in mind as you go through the procedure. Now, if you want to, say, measure the unknown resistor, then you want to use the black connector on the bottom, and you're going to plug it into the prongs over here. Now it is securely connected, so it's not going to fall off. And if you look underneath, there are some wires you can see, and what this does is makes a complete circuit from the power supply to the reference resistor to the variable resistor to the circuit element. In this case, it is the unknown resistor, and then it goes back to the power supply. So that allows the circuit to be completed when you have plugged in the power. When you want to reverse the circuit element, so when you want to reverse the voltage that is being applied, you're going to unplug it, and you're just going to turn it 180 degrees. So basically we want to reverse the connection on the bottom here, and I'm just going to turn it and now plug it in this way. And again, it's securely connected. So by plugging it in this way, that reverses the direction that the voltage has been applied across my circuit element. So the unknown resistor is fairly easy to identify. The diode is also fairly easy to identify. It's just this little black cylinder. And then in terms of the two things that look like light bulbs, one of them is a light bulb and one of them is a diode. So if you look closely at the inside, the light bulb, you can actually see the little filament, whereas the diode has some metal shapes on the inside of it. And when you plug them in with the power supply turned on, the diode will glow a sort of yellowy orangish color, whereas the light bulb will be more of a white light, so it'll look more like a typical light bulb. So that is how you can tell the difference between the LED or the light emitting diode and the standard incandescent light bulb. We have our multimeter here. It is currently turned off, and you can see around the dial that there are different units. Those represent the different types of quantities you can measure with the multimeter. Now, in this lab, you need to make measurements of resistance. So you'll need to look for the ohm setting up here, meaning when the dial is pointed up there, you will get resistance measurements. And we also want to make measurements of voltage, but there are several different settings for voltage. So what we want to measure is DC voltage, or voltage for a direct current circuit. So the correct setting for voltage would be the V with the straight line and the dotted line. We won't worry about the other settings right now. And on the bottom of the multimeter are the plugs for the test leads. So for these wires here. And you want to take the rounded ends and connect them to the appropriate terminals. So the negative terminal is a common terminal for all the different kinds of measurements. So that one is the COM terminal. And following standard conventions, I'm going to use the black wire for my negative terminal. So I'm just going to plug that in there. Now the positive terminal depends on what type of measurement you're making. You can see on this side, we have the A symbol for amps, meaning these connections here are used to measure current. And then over on this side, we have V, ohm, and a few other things, meaning that this side is the side we will use for both voltage and resistance measurement, which is convenient. So I'm going to take my red wire and connect it to this terminal here. And these can just stay in place for all of our measurements. And the other end of the test wires are two metal prongs. So these are the probes that we're going to use when we want to make our various measurements. So I'm going to start off by doing a resistance measurement. So I'm going to take this dial and click it until I get to the resistance setting. And right now it's reading OL for overload. What it's trying to do is measure the resistance between the two prongs, but they aren't connected to anything. So it's giving you basically a nonsense reading. Now, what I want to do is measure the reference resistor on my IV baseboard. So on the reference resistor, what I want to do is connect my probes to the wires on either side of the resistor because they are electrically connected. Note that the power supply is not connected anytime I'm making a resistance measurement. So I'm going to lay this flat here, and a resistor does not have a designated positive or negative side. So it actually doesn't matter whether I connect the red or the black on which side. And I want to carefully touch the metal parts of the probes to either side of my resistor. And you can see after a second, I'm getting a reading on my multimeter. And up on the top of the multimeter screen, you can see the omega or the ohm symbol. So this reading is approximately 75 ohms. And it is normal to see a little bit of fluctuation even on a digital display like this. So you can take that into consideration as part of your uncertainty for the measurement. So yes, the digital multimeter does have uncertainty. That will be discussed in a separate video. So I can record the resistance of my reference resistor on the baseboard now. And you are also required to measure the resistance of your unknown resistor. So that's this one here. And this one has some wires on either side of it, but it's actually rather difficult to try to measure the resistance by touching the probes on either side of this wire. It's just pretty finicky. It's hard to get a good solid measurement. So what I would recommend instead is that you connect the unknown resistor to the IV baseboard. And you can see next to the next to the prongs, there are two wires on the baseboard that are connected electrically. So I can use the probes and touch them on these two wires here. And again, note that the power supply is not connected. So anytime you're doing resistance measurements, make sure the power supply is not connected. So I could connect the wire or could connect the resistor either way, but I'm going to connect it facing this way so that I can easily see the wires. Now I can use, again, doesn't matter, positive or negative, I can use my two probes, touch them onto the wires on the baseboard, and I'm going to, after a minute here, hopefully it will settle down. I'm going to get a reading of the resistance. And again, a little bit of fluctuation in the reading on a digital display is normal. If you accidentally touch the baseboard or anything else on the circuit, you will get sort of a nonsense reading. So be careful that you are touching on the wires here and not on any other part of the baseboard. In order to use the multimeter to measure the voltage across either of your resistors or any of your other circuit elements, first of all, we need to put the multimeter in the correct setting. So right now it is on the ohm setting because we were measuring resistance earlier. So I'm going to make it go 2 clicks counterclockwise and put it into the voltage setting. And right now I'm just getting a 0 reading. There is a little bit of fluctuation, but right now the multimeter is just trying to read the voltage between the two probes, which aren't connected to anything. So this is not a meaningful display at the moment. And in order to measure the voltage across my resistor, again, I can do the same thing as I did with my resistance measurement. I just want to touch the probes on either side of my resistor. You can see I have a reading of 0 right now, and that is because the power supply is not connected. So it makes sense that I'm getting a reading of 0 volts. So what I'm going to do next is connect the power supply, and I'm going to take my unknown resistor and connect it to the circuit as well. So I'm going to plug it in this way. Now I have a complete circuit, and I'm ready to measure the voltage for my IV characteristic curve. Before I start though, I'm just going to take my variable resistor and rotate it all the way counterclockwise. And now I'm going to take the two probes, connect them across either side of my reference resistor, and I have my voltage reading. Now for the same setting of my variable resistor, so without changing the variable resistor yet, I want to get a measurement of the voltage across my unknown resistor for this same setting. So I'm just going to turn the baseboard a little bit, and remember I have the wires underneath my unknown resistor that are used as my test points. So at the points where I can make measurements across that resistor. So I'm going to take the two probes and connect them to the wires so that I can measure the voltage across my unknown resistor. So after it settled this down, then I can see I have my voltage reading here. So this would be your first point for this set of data for your unknown resistor. In order to get your next data point, you will want to turn the dial on your variable resistor. So I'm going to turn it clockwise a little way, and now I'm going to make a new measurement. So I've got a new data point, and measure the voltage across my reference resistor. So I have a new value here, but before I turn the dial on my variable resistor, I need to also measure the voltage across the unknown. So connecting the probes to the wire underneath the unknown resistor gives me my voltage reading, and that gives me my second data point. And you can continue like this. So turn up the dial on your variable resistor and continue to make pairs of voltage readings for the reference and the unknown resistor. When you are ready to reverse the resistor and make the measurements in the negative direction, first I would recommend that you turn the dial all the way counterclockwise once again, and then you're going to remove the unknown resistor from the circuit and rotate it 180 degrees. So now it's facing the other way. That reverses the connection at the IV baseboard, and it reverses the direction that the voltage is being applied across your unknown resistor. So to get a data point, then I would do the same thing, measure the voltage across my reference resistor, and then using the test wires, measure the voltage across my unknown resistor. But because we are measuring the voltage in the reverse direction for our unknown, we are going to record these as negative voltages. So even though it doesn't say negative on the display, record them as negative because we know that the voltage is being reversed across this resistor. And if I turn the dial on my variable resistor a little bit, then I can make a new measurement, so a new data point for the voltage across my reference resistor and for the voltage across my unknown resistor. So in order to fill out the IV graph, you would continue getting data points for the negative side of your IV graph, meaning you have the unknown resistor in the reverse position.